All right, we're looking at the second section of our notes. The distance formula is what we're talking about today. Okay, so that essential question, how can I determine the distance between 2 points? Okay, that is the entire goal of what we're going for today, our learning target. We are trying to determine the distance between 2 points. We're talking about 2 points that are on an XY plane. So you're going to need your notes packet, and you're probably going to need a calculator because we're going to have some pretty complicated looking formulas going on in this one. All right, let's go on to first talk about something that we have seen before. Okay, something called the Pythagorean theorem. You talked about this way on back in your way on back in your old times of middle school math. You talked about the Pythagorean theorem. Okay, the Pythagorean theorem, it all has to do with right triangles, and you've got the two legs of that right triangle, A and B, and there's a formula that relates A and B and C, the hypotenuse of that triangle, and that's this formula right here. A squared plus B squared equals C squared. This is something that works for every single right triangle that has ever existed. The sides are always in this, they always have this relationship to each other because of that right angle right there. So keep in mind that C is the hypotenuse here. C, the longest side of that triangle, and is the side that's not touching the right angle. Okay, we've talked about the Pythagorean theorem before, but I guess the question is, how does that relate to distance formula? Okay, how are we going to bring this back into what we're looking at today? And it's like this. Imagine you had your right triangle, and it was laid out on a coordinate plane, an XY plane, and all of your points at the corners, A and B and C, those are all at specific points that are given on that coordinate plane. When we look at this side, AB, that is the longest side of our right triangle, right? That is the hypotenuse. And so when we're using the Pythagorean theorem, that is our C. Okay? The distance of A to B is whatever the distance of point A to point B is whatever that distance is right there, whatever the length of that side is. And so when we talk about the Pythagorean theorem, look at this. We always have A squared plus B squared and C squared. Okay? We never have just C by itself. And if you'll think back to that middle school math class when you learned about this, the way that we figured out what C was, okay, because the question was almost never what is C squared. Most of the time, the question was asking what is C. And so to find that, we had to get in this equation, we had to get C by itself. Okay, and the way we did that, the way we got rid of that exponent right there, was by taking the square root. And when you take the square root of something on the right side, you have to take the square root of all this stuff on the left side too. So that's what we did. To get this C by itself, you had the square root of a squared plus b squared. So when we have a squared plus b squared like that, we had to take the square root of both sides to have that c by itself. Well, that's exactly the approach that we're going to take today to find the distance between 2 points. Okay, a lot of times, as we talked about yesterday, it's very difficult to count, one unit at a time and figure out the distance between the endpoints of a line segment when it's going diagonal like that. So what we're going to do here is give us a new formula that's related to the Pythagorean theorem, but it's a little bit different. Okay, so we already said that C was the square root of a squared plus b squared. The distance, the length of that side was related to the lengths of these two sides of the triangle. Well, imagine for a second that we didn't have these two sides of the triangle. All we had was just this length right here. All we had was just this line segment. Okay? Our new formula, if we were looking for that, we would still need to know the distance between the y values of those 2 points. We would still need to know the distance between the x values of those 2 points. Y'all, when we look at a triangle like this, that's what A and B are. A is the change in y values, the vertical change between point B and point A. That's the length of this side of that triangle. The horizontal change, the change in the x values from point A to point B, that's the length of this side of the triangle. So our new formula looks kind of like this. The distance, instead of a squared plus b squared, the distance is the change in x values squared plus the change of y values squared. Okay, it's all related to the Pythagorean theorem that we already know how it works. So your question is, what's this little triangle thing? Okay, first off, that means change. Okay, when you see the triangle, that's actually a Greek letter called delta, and it comes up in a lot of your science classes. It means a change in y or a change in x. And the way you find the change in x values is by finding the difference. You subtract your x values from one point to the other, and then you subtract your y values from one point to the other. And so this right here is our distance formula. This is what we get for our distance formula. And it looks super duper complicated. But just like yesterday, all of these things that go under here, those are all just numbers that we're going to plug in. And there's a lot of stuff that can simplify, and a lot of stuff that when you punch it into the calculator makes it a lot easier on yourself. All right. So take a second and write that down. Pause the video if you need to. We're going to look next at the example problems. There are two examples right here. Okay, the first one is this. Find the distance between these 2 points, negative 2, 1 and 1, 5. So we have this big old formula. Okay, it's going to be helpful to us to identify what is x1 and x2, what is y1 and y2. So something we can do with that is just label it on your paper. We're going to call that x1. We're going to call this one y1. We'll call this one x2. We'll call this one y2. We can do that. That's a perfectly acceptable thing to do. Just label it right there on your paper if you're afraid you're going to get confused. So all we're doing is plugging in these numbers into that formula. x1 minus x2 becomes negative 2 minus 1. Negative 2 minus 1. y1 minus y2 becomes 1 minus 5. All that stuff right there. Okay? If you wanted to just stop right here and punch all of this stuff into the calculator, that is a perfectly reasonable thing to do, and you are absolutely allowed to do that. However, I do not recommend it because your negative signs and your minus signs are so easy to mix up. And it is so, when you're typing in this many things, it is very easy to get mixed up and miss one of your parentheses, or mix up a negative sign and a minus sign, or it's when you're typing all of this whole mess of stuff into the calculator, you've got so many opportunities to mistype something and end up with a wrong answer. So what you can do instead is simplify it as you go along. Just off the top of your head, this is a very simple thing. Negative 2 minus 1 is negative 3. 1 minus 5 is negative 4. So simplify that as you go along. And then when you get to this point, it's really easy too, because you've got this. You've got negative 3 squared. Well, that's just negative 3 times negative 3. So you know that it's positive 9. Same thing with negative 4 squared is positive 16. This right here is something you can simplify. And this, let me tell you, this right here, so much easier to type into the calculator than all this mess of stuff. Okay? A lot less opportunity, a lot fewer opportunities to mess yourself up typing this in compared to this. So as we move on down, we actually see that it's 25, and the square root of 25, well, that actually is a perfect square, isn't it? So our distance ends up being a nice whole number. Our distance ends up being right at 5. And that's very useful. It's very convenient that it turned out that way. But let me tell you right now, most of the time, it is not going to turn out that way. And you're going to have to punch stuff into the calculator. Okay, let's go look at that next problem. That next problem is a great example of it. Okay, we have our distance formula with x1 and x2, y1 and y2. And all we have to do is plug those numbers in, right? x1 and x2, we've got 7 and 3. y1 and y2, we've got 8 and 2. Okay, we subtract all of that stuff. We simplify things down as much as we can. We end up with 4 squared right there. We end up with 6 squared right there. Well, we already know, because we're brilliant students, we've done this before, that 4 squared is 16, 6 squared is 36. You learn multiplication starting in like second or third grade, somewhere in there. Okay, we know how to do this. The thing that we have a little more trouble with, though, is 16 plus 36. How do you take the square root of 52? Well, that's not a perfect square. So that is something that you would have to type into your calculator. Again, if you wanted to just type in all of this into the calculator right off the bat, you can do that. But it's going to be much more helpful for you to simplify things as you go as much as you can, and then punch into the calculator something that's a lot easier to deal with. So when you type in the square root of 52, it gives you a big long decimal because it's not a perfect square. But we're going to round it off, and we're going to say that that distance is 7.21. All right? 7.21. Now, as you're going through the Canvas assignment for this part of Topic 5, make sure when you use the calculator, you are being very careful with your syntax, okay? Make sure you know the difference between the negative sign and the minus sign, okay? Make sure you know where to put parentheses, okay? I want you to try something in your calculator. Type in, with no parentheses or anything, just type in -3 and then give it an exponent of 2, so -3 squared. The answer is not what you would think, okay? When you type in -3 raised to the exponent of 2, that gives you an answer of -9. But wait, that doesn't track, okay? Remember that a negative times a negative is always a positive, so -3 times -3 should be +9, right? Okay? Your calculator does not see it that way. What your calculator thinks is that you typed in 3 squared, and it thinks you're looking for the opposite of +9, which is -9. Okay, that's why it gets that. So you have to be really careful when you're typing things into these calculators, because they're basically just tiny computers. Okay, they follow the commands that they are given. And that means you have to be very specific and very careful about what commands you're typing in, because a calculator is going to give you the output exactly as you requested it. You just have to make sure that your request, your command, your input into this calculator, into that tiny computer, you have to make sure that you're typing in the right thing. All right? So watch out for that as you're working on these problems. That's all we got for today. Y'all have a good one.